Assalamualaikum warahmatullahi wabarakatuh and good day to each and everyone. So this is Sir Hanif, your instructor in EE223. So once again, this is the continuation of our discussion from our last meeting. Okay, so last meeting we have already discussed the basic and fundamentals for matrix and operation or linear operation of matrix. So this time we will continue our discussion for linear algebra pa rin, but this time our topic is eigenvalues problem. Okay? So once again, please keep on this discussion for more information. Okay? So now we have here an eigenvalues problem. Okay? So basically, we will just apply what we have learned from our previous discussion for matrix and its fundamental uses and techniques. Okay, um, so we have here an eigenvalues. Okay, so we have here a linear algebra, uh, particularly a matrix eigenvalue problem. So the matrix eigenvalue problem considers the vector equations. We have here vector A multiplied by the x, okay, where x is also a vector, is equals to lambda multiplied by the x, where x is also a vector. So they have the same. Okay, so vector A, vector x, and the const or scalar lambda and vector x. Okay, so we need this equation. This equation is called as a eigenvalue. I mean, this equation is called is a matrix eigenvalue. Okay, so as you can see here, throughout this discussion, we will notice how to perform a matrix multiplication of two matrix. Okay, so the lambdas here that satisfies this equation once is called as eigenvalues of A. Okay, take note of that. So basically, we have such different values of lambda, which can be satisfied, which can be used to satisfy this equation here. Okay, then the corresponding non-zeros x that also satisfies this equation one is called as eigenvector of A. Okay, so take note of that. Yung lambda natin here, yung values ng lambda natin dito is called as eigenvalue, and the value the values of this x here is called as an eigenvector. Okay? So uh the matrix eigenvalues problem, determining the eigenvalues and eigenvectors. So we have here to consider a multiplying a non-zero vectors by a given square of matrix, such as if we multiply this one, there will be a resulting vector, no, as what we have just described on our previous discussion on how to multiply the two matrix. Okay, so you just have to follow that one. Now, so how to find the eigenvalues in eigenvector? So instead of defining that one, we must consider an example of that one to surely understand what will be the importance of these eigenvalues and eigenvectors problem. Okay, so we have here uh, example one. So determining the eigenvalues and eigenvectors. We have here a vector A, which consists of an increase of -5, 2, 2, and -2. Okay, so if we multiply that vector A, uh, if we multiply that matrix A with the vector x1, x2, okay, and satisfies the equation of eigenvalue, no, this one, eigenvalue problem, okay, um, this is vector equation. If we satisfy that one, so we can actually have these equations. We have the matrix A multiplied by the vector x. So ito yung vector x natin is equals to lambda multiplied by the vector x natin. So ito yung vector x natin. So in components, we have, if we multiply this, okay, if these two vectors and then equating that one here sa multiplication of vector na to, so we can have these equations. We have negative 5 multiplied by x1, so ayun siya. Then 2 multiplied by x2, so ayun siya, is equals to lambda multiplied by x1, so ayun siya. Then the other one, the other equation can be have using these two values here. So we have 2 multiplied by x1 again, and negative 2 multiplied by x2, so we add mo yun siya, so ito yung results sa kabilang side dito. So then lambda multiplied by x2, so ito yun siya. So these two equation can be used to have the value of our lambda, which is called as a eigenvalues. Okay, eigenvalues. So um, what we have to do is to satisfy this equation. Okay, so we will be substituting this constant 5 here uh, with the other values, in which we subtract that one with the lambda here. Okay, so as you can see here, yung negative 5 na to, instead of negative 5, naging negative 5 minus lambda siya. And diagonal, pa-diagonal siya, no? So itong mga constant dito at saka ito, so maminusan natin siya ng lambda. Okay, so negative 2 minus lambda. But the other side here will not be changed, no? So we will no longer change that one. Okay, so this equation here is to be solved, and then equating that one to 0. Okay, since this equation here is defined uh, for this matrix to be equals to 0. Okay, so um, if we take the uh, form of these two equation here into a matrix form, this one, then equating that one to 0, as has been suggested by this equation. Okay, so equating that one to 0, so we can now find this equation here. So I have already introduced to you how to calculate the matrix. Okay, if we have a matrix, we just have to perform a uh, multiplication here, then multiplication, and then subtract mo yun siya. Okay, then you will have the value. Okay, so as just has been performed here. Okay, so ito yun siya, final value. Now, taking this equation here is equals to 0, we can now find the value of lambda, definite value of lambda, which is equals to negative 1 and negative 6. Okay, so you can just use a quadratic equation to have the roots of this equation here, or you can just use a calculator to find the roots of this one. Okay, so in this case, diniretso na natin yun siya. So, lambda 1 is equals to negative 1 and lambda 2 is equals to negative 6. So, once again, these values here is came from this equation here. Okay, so, eigenvectors of A corresponding to lambda 1. So, since meron na tayong eigenvalues, these two values here is called as an eigenvalues. Since meron na tayong eigenvalues, we have now to find the value of eigenvector. Okay, so finding the eigenvectors, we will just have to substitute these values of lambdas here, dito sa ating dito sa ating equations, right? And in that case, we can now find the value of x1 and x2. Okay, so yun. Okay, so then after that, same for the other values of lambdas, which is for lambda equals to negative 6 here. Okay, so we can same, you can just find the substitute the value of lambda. Okay, okay, so then you can find the value of x1 and x2 here. Okay, so which is we have a vectors of x2 here. Okay, so that's how to find the value of eigenvalues and eigenvectors. So please read these. No, in this discussion, I have not discussed, or I have not said any I have not discussed this instruction here. So since I have already illustrated how to get that one, so in your assignment is to read this. Okay, so just read this and you will understand how I got the values of eigenvalues and eigenvectors. Take note that the only important here is to consider is to get the value of eigenvalues, okay, which is the lambda, and then yung eigenvectors natin, which is the x, that satisfies this uh, vector equation. So yun lang yung pinaka-importante talaga, no? That's how we determine the values in order to satisfy this equation. Okay, so now we have here a theorem. Okay, sabi dito, the eigenvalues of a square matrix A are the roots of the characteristic equations of A. Okay, so hence, on n by n matrix has least at least one eigenvalues and at most n numerically different eigenvalues. Okay, so if you are about to solve eigenvalues or eigenvectors, make sure to consider this theorem. Okay, so theorem 2. So we have here an eigenvectors or eigenspace. If W and X are the eigenvectors of a matrix A corresponding to the same eigenvalue lambda, so that um, W plus X, provided that yung X natin is not equals to negative W and Kx for K is not equals to 0. Okay, so hence the eigenvectors corresponding to one and the same eigenvalues of lambda of A together with 0 form a vector space. Okay, so called the eigenvalues of A corresponding to that lambda. So dapat talaga is you have to consider the space of the eigenvectors before you perform any uh, manipulation on that equation. Okay? So the order of the order um, lambda A of an agent okay, wait lang. Hindi ko maklaro. Okay, tama. The order of lambda, the order of lambda, the order of lambda of an eigenvalue of this lambda, okay, as a root of the characteristic polynomials is called as the algebraic multiplicity of lambda. And the number of m lambda of linearly independent eigenvectors corresponding to this eigenvalues lambda is called as a geometric multiplicity of lambda. Okay, so these are just the name of that, no? So yung order at saka yung name ng ating eigenvalues. Thus, m lambda is the dimensions of eigenspace corresponding to this lambda. Okay. So example number 2, we have here an algebraic multiplicity, geometry multiplicity, and positive deflect. So we have here um, the characteristic equation of the matrix A is this one, no? So we have already known this, no? Ito yung equation, di ba? Do you remember here? Do you still remember here the how we can get the lambdas or yung ating eigenvalues? We have to satisfy this first, no? We have yung kuan muna natin, itong equation muna natin dito, yung pa-diagonal niya, as I have said kanina, is maminusan mo muna natin siya ng lambda. And after that, we will perform a matrix operation, then equating that one to 0. So, same as what we have to do here dito sa example number 2. So, we have, ito yung original natin na matrix, tapos maminusan natin yung pa-diagonal niya na kuan, entries ng lambda. So, ito yung nangyari. So, we have here negative lambda, then 1, 0, negative lambda, then performing a matrix operation in that case. So, we can just, and then equating that one to 0. So, we can have this lambda squared is equal to 0. So, hence, the value of lambda is equals to 0 is an eigenvalue of algebraic multiplicity of m sub is equals to 2. Bakit? Kasi dalawa yung value natin na 0 eh. Okay, so it has a 2 multiplicity. But its geometric multiplicity is only m sub is equals to 1, syempre. Kasi hindi natin pwedeng gamitin yung dalawa kasi nga they have the same eigenvalues, right? So dapat talaga is yung isa lang. Okay? Since eigenvalues or eigenvectors results from 0, x1 plus x2 equals to 0. So when we substitute the value of lambda is equals to 0 dito sa equation na to, okay? So mangyari ka ito yun siya. So therefore, x2 natin would be equals to 0. Okay? x2 would be equals to 0. Then this would be the resulting vectors. Okay? So the other one is ito yun siya, another example. So same pa rin, no? Same procedure, okay, to get the eigenvalues and eigenvectors. So okay, So I think that's all for eigenvectors, no? Eigen eigenvectors and eigenvalues. So please have on that as much as possible. Okay. So now let us proceed to a vector differential calculus. Okay. Vector differential calculus. So same as what I have said, we will just apply on what we have just learned from the previous discussion on this other part of our discussion. So we have here a vector differential calculus. So most probably in here, we're dealing with a scalar or two-dimensional or three-dimensional space. Okay. So before that, we first define a scalar. A scalar is a quantity that is determined by its magnitude only. It takes on a numerical value. And number examples of scalars are time, temperature, length, and distance, speed, density. So in short, pag scalar ka, hindi mo kino-consider yung kanyang direction. And for the vector naman, it is a quantity that has both magnitude and direction. Okay, so it's an opposite of a scalar. An example of a vector is a velocity, no? Um, it's because it has a magnitude at the same time it has a direction, displacement, and force. Okay, so yun. They are both an example of vectors. Okay, so a vector arrow has a tail called its initial point. So in a way, vector can be represented as a arrow, no? Take note of that. And its tip, okay? Its tail is called as an initial point. So, ibig sabihin yun yung pinagmulan niya, and its tip is called as a terminal point. Okay? So when you have a vector, you can represent that vector using a an arrow that its tail is suggests its initial point, and its tip is suggested by its terminal point. Okay, so we have here definition. So equality of a vectors. So two vectors A and B are equal, written as A is equals to B if they have the same length and the same direction. Okay, so you can just say two vectors equal if and only if they have the same direction at the same time they have the same magnitude. Okay, so if that is not satisfied, you can not say that the two vectors are equal. Okay, so dito tayo sa component of a vector. Now, a component, we choose an XYZ Cartesian coordinate system in space in general. Okay, so what is this Cartesian coordinate system? That is the XYZ coordinate, no? We do familiar with that one already. Okay, so it means that if we have a vector, we can have its component with that with respect to that Cartesian coordinate by using this definition here. So that is a usual rectangular coordinate system with the same scale of measurement on a three mutually perpendicular coordinate axes. Okay, then let A be a given vector with the initial point of this one and terminal point of this one. Then the true coordinate differences is suggested by these equations. We have for coordinate 1 is the subtraction of the component along x, no? X2 minus x1. And for coordinate 2, we have y2 minus y1. And for coordinate 3, we have z2 minus z1. Okay? These are called a component of a vector. Okay? With respect to a Cartesian coordinates. Okay? So, here is the physical representation. No? So, for example, um, if we have here a vectors, no, it has a component along x, along y, and along z. Okay, then its magnitude is suggested by this equation here. Okay, so we have just to take the square root of a1 squared plus a2 squared plus a3 squared. Okay, so that is already familiar with us, no? So we have here an example. We have components and length of the vector. So please be familiar with this one. This is just an application of how to get the component of a certain vector. Okay, and its magnitude right here. Okay, now, so dito tayo sa vector additions and scalar multiplication. Okay, so we have here different properties of how to add a vectors. So definition, we have here the addition of vectors. So So if you have the sum of A and B, which A and B are two vectors, that has a component of A1, A2, and A3, B1, B2, B3, is obtained by adding the corresponding components. So for example, if you have two vectors, this one and this one, no? So what you do is just to add the its component, no? To what you will do is to add the component of the two vectors to add them as a whole. Okay? So yun yung gagawin natin. Now, if it is represented naman by a graph, so kung meron kang vector A and meron kang vector B, so what will you do is just to connect the tail of second vectors to the tip of the first vector. Then after that, you connect the tail of the first vector to the tip of the second vectors. Then the resulting is yun yung resultant natin na vector. Okay? So basically this can be applied with the situations like this one, no? For simplification. We have here a different rules on how to perform an addition of vectors. So please refer on this one. Okay? So we have here definition. So dito na naman tayo sa scalar multiplication. So for scalar multiplication naman, if you have a vectors that is composed of this A, okay, composed of this A, so we have, if we multiply that one by a scalar C, so um, what will you do is just to multiply the scalar C to each of the component of the vector. So just as what we have done here. So we have C is equal, C multiplied by vector E is C A1, then C A2, then C A3. So you just have to distribute that one on its the component, okay, along the Cartesian coordinates. So these are the basic properties of a scalar multiplication. So please refer on it. Okay. So well, basically, we have here an example, no? So please refer on that one. So basically, we in this vector calculus, we are dealing with the uh, um, XYZ Cartesian coordinates. So we are using ijk as a unit vector. So we are using that unit vectors to represent the um, the vectors, okay, in terms of its component along x, y, and z direction. Okay, so as you can see here, the component of I is in terms of 1, 0, 0. The component of j is in terms of 0, 1, 0, and the component of k is in terms of 0, 0, 1. Okay, so we have here, no? So dito tayo sa inner product or dot product or orthogonality. So if you have two vectors that are expressed in two or that are not the same, then if we take its dot product, it is defined by this equation. Um, we have a b cosine of alpha, where a should not be equal to b, 0, and b should not be equal to 0. Now, if the dot product of a dot b mo is equals to 0. So therefore, yung a mo is equals to 0 or b should be equals to 0. Okay, if it that exists. Now, generally, if the vectors are expressed in terms of their component along the xyz coordinate, uh, um, for you to be able to have their scalar product, all you have to do is to multiply the their components along the different coordinates and then add them. So for example, is this a dot b. So what we have done here is a1 b1 plus a2 b2 plus a3 b3, where a1 b1 is the component of a and b along x component, and a2 b2 is the component of a and b along y axis, and a3 and b3 is the component of a and b along z axis. Okay, then add them. So that will be the result of a dot b, or inner product or dot product. Okay, so I think these are all self-explanatory, okay, with regards to the dot product. So please refer on it. Okay, so I have here different problem sets. Okay, so please have on it. Okay, or answer this as a whole and submit it to me right away. Okay, so I think that's all. If you have any question regarding this discussion, kindly ask it to me right away para hindi tayo mawala. Okay, so that's all. Assalamualaikum warahmatullahi wabarakatuh and good day everyone.